Hello, and here we are for section 3.9 of Math 980. And in this section, we are revisiting solving equations, but we have a couple of new features to the equations that you may not have had the chance to solve before. So here we have a square root of 3x equals 3. And when we're solving equations, we're trying to get the x isolated all by itself on one side of the equal sign. So how would I undo a square root? Well, we call this an inverse operation, so it's like an opposite. So the inverse of square root is to square something. So squaring and square rooting act as opposites. They undo each other. So if I want to get rid of the square root, then I would square it. But of course, whatever I do to one side, I have to do to the other side because it's an equation. And so this becomes just 3x. So the square root and the square cancel each other. And this becomes 3 times 3, which is 9. And then I undo the multiplication by division. So x equals 3 is my answer. All right, let's look at the next one. So these, let me see if you can see the numbers here. There you go. So that first one was problem 1 from your homework. So the second one is problem 2. And we're going to first divide the 7 so that we can start getting the z isolated. I get z squared equals 4. Now remember, the opposite of squaring is square rooting. So squaring and square rooting are inverses of each other. So if I square root this side, I would then square root that side. Something to be aware of. If you are the one to put the square root there, then you have to account for the fact that there are 2 square roots of 4. You could have 2, because 2 times 2 is 4, but you could also have minus 2, because negative 2 times negative 2 is 4, right? 2 times 2 equals 4, but negative 2 times negative 2 also equals positive 4. So we have 2 answers. Now, if, like here, the book had put the square root there and they did not account for the plus or the minus, then you don't worry about it because they would have to put that out front if they've already written the square root for you. But when you're the one putting the square root in, you have to account for the plus or minus. So it's not that they didn't account for that, but because they didn't include the minus, they were only writing this equation for the positive piece of it. And had they wanted the negative piece, they would have put the negative there. So just remember that when you take a square root of something, you have to account for a positive and negative answer. There's a shortcut for writing both of those answers, and that would be plus or minus 2. And there is a plus or minus key on your menu at the bottom of your screen. Okay, so how about this one? I have my x down in the denominator. How would I move it? Well, we could do cross multiplication. So we could multiply the x plus 2 times the 2. If I pretend that's a fraction, then the 1 times 1. So I get 1 equals 2 times x plus 2. And now it's up where we can deal with it. So I would distribute next. 1 equals 2x plus 4. And then subtract the 4. So I get, this becomes negative 3 equals 2x. Let me write that here. Negative 3 equals 2x. And then my last step, I would divide by 2, and I get x equals negative 3/2. All right, let's look at number 7 real quick. It's a story problem, and it gives you a bunch of information, but the important thing is it gives you this formula, and the S stands for nonsense syllables, and the I stands for the IQ score. And in my problem, they said, if the nonsense syllables were 11, then what would the IQ score be? So I would replace the S with 11, and then I would solve this equation. 2 square root of I minus 9. So I'm going to pick off these outside pieces first. So I'm going to add 9. I get 20 equals 2 square root of I. Divide by 2. And I get, let me write it over here, this becomes 10. And that cancels square root of I. So I'm going to write that 10 equals square root of I. How do I get rid of a square root? I square it. So I square that side, so I get 100 equals I. So the IQ would be 100 when there are 11 nonsense syllables. Okay, the last question I'm going to talk about is number 9, where they have this tree and they want you to find the height, and they give you this, they create a triangle out of the picture and they give you this distance and that distance. So the best way to solve it is to use the Pythagorean theorem. A squared plus b squared equals c squared, which works on a right triangle, which they've created here. The c, remember, is always the hypotenuse. It's the longest side, right? So that's that one. So we could call this one a and this one b, doesn't matter, or we could leave it as h. So if I use this formula, then I would write 15 squared plus the height squared equals 31 squared. So the next thing I would do is go ahead and square those numbers. So what is 15 squared? It is 225 plus h squared equals, and 31 squared is 961. Then I would subtract 225 and I get h squared equals 736. And what's the last thing to do? Take the square root of both sides, right? Now, remember, if you take the square root, then you have to account for a positive or negative. So I'm going to get h equals, what is the square root of 736? And they want it rounded to 1 decimal place. So I get plus or minus 27.1. Now that's mathematically the correct way to do it. But then we have to consider the fact that this is a story problem, so it has a real life application. Could we have a tree height that is negative 27.1? And the answer is no. We don't measure height in negatives, so therefore, because this is a story problem, then we just leave the positive. So that tree height is 27.1. And that's it. I'll see you later.